Hello everyone, welcome back to our CATIA Automation Tip sessions. My name is Mansu Kim. I'm an automations consultant working at the Impararia Solutions. Today's content is about the instantiating with the RC system. So let's look at the first case, the without the RC system, what the result look like. So I prepared so this is the kind of detail templates, and you have old configurations upper side, and finally you will have the output automations here. So let's try to learn it. So these automations will create the final component, which is piece by piece. In this case, just a Boolean right body. So this was here instantiate under the sub assembly of the detail template assembly. So sub assembly will have here the final component that you might have the final materials or some BOM informations or such things you can define. But for now, I just make it as a simple, so don't have any much things. Now, maybe for the future, I will decorate more for another automation tip sessions. By the way, so today's topics about the asset system. So here's when you look at the final component, and the base asset system of the final component is here. Still the origin of the where the located in the skeleton level. So it's same as here. So it's the same place because we didn't move any location using the engineering connection here. So this often causes the problem of your next behavior of your component configuration. For example, the direction might be different, the location might be different, and you need to figure out the drawings, the view location again. But imagine that if your item is always in the center of the RC system, and your component is located by managed by the RC system. Okay, so that will be the one of the nice way to configure the options. So let's look at the manually how it works first. So when you have the assembly, and then I will change it to the application called the assembly. So here assembly design and assembly tab, you will have the engineering connection that you can connect the RC to RC. So actually I prepared the RC system here already in the skeleton detail modeling skeleton. So here we have the RC system. So we have RC system here, and we have the RC system here as a final component. So I'm going to matching those two. So when you click engineering connection and click the coincidence, and the first selection, it will be this RC system, and the second option will be this RC system. So it's moving, the object is moving. The problem here is that not the final components is moving, but the assembly level is moving because I'm accessing here the assembly, and this is sub-assembly, but here the final component are located under the sub-assembly. So this doesn't recognize if you doesn't check the contextual recognitions. So imagine that if you have many Boolean and transom in under this sub-assembly, then just when you fix creating the engineering connection, just pro 1, assembly is already fixed, so you cannot use this way. If it's one level, it will be no problem, but if you have a sub assembly, then you need to check the option here, engineering deep connection option, the advanced options that allow conceptual connection. So by doing that, not moving this assembly, but you can move this one. Okay, so I will cancel it and I will try again. So let's access again the engineer connection. People to access to use the contextual menu, you need to wanna work on the open this assembly, because we have the higher assembly. So contextual might be captured at the higher level. So it's you should access like that. And now you should access in this sub assembly. So you can create the contextual connection, engineer connection. So now let's look at the option again. It's checked. Then create the coincidence, and from the ASCII system, yeah. And usually you cannot click the another ASCII system if it's undefined, so you cannot select that. But since it allows the contextual connection, now you can select the another assembly, higher level of the assembly. So contextual support is successful, and they create. Now the right component is moved, not the assembly level. Then click OK. No crash. So that's the things how it moves. Of course, this is the object is linked now. So only what you need to do is the update. So the object is linked from the skeleton level, and this is properly working here. So this the manual work we can automate in the process. So I will just delete. Also, just for the comment for the deleting, also if you only delete the component, then you also might error for the connection, cannot find the component. Therefore, in your automation script, you need to delete the engineer connection first. After that, you delete the component. So without error, causing the error, it will be updated well. So now let's look at the case 2. Let's try to instantiate the automated one for creating the final component under the sub-assembly and creating the engineering connection altogether. Since creating the engineer connection, you need to have the instance in the script to understanding the path of the ASCII system. So there's some you need to careful. The first thing is that the location of the ASCII system, if it's recognized from the high level by the name and the geometrical set until reaching the ASCII system. And this case is fine, but in the transom middle, in this case, if you have output and you have some configurations already that creating or delete by some parameters. So in this case, you will have the ASCII system, of course, but if the instantiated object name is the same, the second one, it will be might recognize the first geometrical set if its name is the same. So be careful when you instantiating. The assembly set should be have a different name. So all the paths of the ASCII system have a different path. So be aware of that. And the second one you need to care for is to use the engineer connection in the assembly and the assembly level. You need to have the engineer connection with the contextual engineer connections. You need to use the instance. So in this case, the top level is not the instance. So we need to use this as instance. So you need to go to the higher level. So here we have it now. This template is in the instance. So I will work here to learn. So then the instance will be recognized. So let's try to learn. Case 2 and this. So these automations will bring each automation of the component. So depends on the component, you will name it in differently, and the name of the engineer connection will put in the different way. So this component, these actions just learn for the action of the behavior. So let's learn the automations. And now the instantiation is finished. So you have the sub-assembly. I will just hide this shape so you will see well. So you have cap, you have a body, and you have a glass. Then since the cap, I missed out the left side, right side of the cap, but that's just not much important for now. So let's hide and see the body and the glass. So it's well categorized, and also it's well located with the engineer connection. So you see here the engineer connection naming should be unique. It shouldn't be overlapping. Therefore, even the instantiate the same one, or even if it's the same reference, you should have the different name for the instance using the instance name, for example. And even the class, yeah, you should have the different name. So the engineer connection, it will not causing much problems. So this is the one of the way you can create the final component in your template. Then let's try to look at how it really works in the project. So before we learn, I will again delete the component, because if you already have all the component, and when you learn it in the project, component should be instantiated first, and will be need to delete again, then recreate. Depends on the configuration of the skeleton level. So it's better to not instantiate yet, but there's some reaction while you instantiate in the project level. The trigger we change the name. When something is changed, then this reaction will allow to run this automation automatically. That is the one of the way without any causing the error. So let's look. I will save the keep modifications. So this 3D shape, even 3D shape, will be hide. So looks like empty though, but it will be instantiated while you in the project. So let's look at the project. You have a skeleton, and you have some inputs, and you have some inputs, and the input is not only the surface but also the parameters. The parameters will allow to change the location and the count of the middle transfer, for example. So let's learn these automations. Okay, now the instantiation is finished. So when you look at the project, so starting from the skeleton level, you have the input surface. From the surface, you just learn the automation, then all the parameters and the details are adapted, and the namings commits are all instantiated well, like this. So when you look at the final component, look like this. And each final component, of course, it will carry on all the IFC informations, and if you need, you might have the drawing, manufacturing drawings, and the information perform table. So after you instantiate in the project, you can still use for the next step, the continuous work. And of course, since it's parametrically created, you can still connection from the top level. So for example, if you want to change the height of the class, you just modify and update it in the product level. So that will be the updated that related the object and parameters, something like this. So that's all for today's, and thank you for watching, and if you have any questions, let me know.